Hi, this is a video to help you find the least common multiple using prime factorization. So there's three words here, least, that are just describing one thing. It's least common multiple. And so in my mind, I kind of have to focus on only one of those words to kind of help me understand the definition. And you kind of, in all of our minds, one word sticks out as the most important of all three of those. And that is the word multiple. We need to make sure that this number is a multiple of all the numbers here, really. And if a number, if we find a multiple of all of 27, of 15, and 6, that means that it has the prime factors of those numbers in its own prime factorization. Okay. So let me restate that. Let me say that. A number is a multiple of another number if that number contains all the prime factors. A number is a multiple of another if the number contains all the prime factors. So when you prime factorize the least common multiple, you should find all the prime factors of all three of the other numbers in that least common multiple. Okay, and there should be no double duplicates or anything like that. A number is a multiple of another number if it can produce all the prime factors of the other number. You could see 12 is a multiple of 6. And that's because when I prime factor 12, you get, we can do it real quickly. It's 6 times 2. And then if I prime factor that, it's 2 times 3. So the prime factorization of 12 is 2 times 3. So the prime factorization of 12 is 2 times 2 times 3. The prime factorization of 6 by itself is 2 times 3. So because 12 contains a 2 and a 3, just like 6 does, therefore 12 is a multiple of 6 because it contains all the prime factors of 6. And that's all it has to. If a number is a multiple of another number, all it has to do is contain all of its prime factors when you prime factorize that number. So any number that has a 2 and 3 in its prime factorization is a multiple of 6. So our job is we're going to find the least common multiple of 27, 15, and 6. Our first job is to prime factor all of those. So I take 27, and that's 9 times 3, and then the 9 is 3 times 3. So 27 in its prime factorization is 3 times 3 times 3. And then 15 is 3 times 5, and I can't break down any of those with other than 3 and 1 or 5 and 1 itself. 6 is 2 times 3. So we need to find now here's where the word multiple or common comes in. So we'll talk about multiple. Multiple means when we prime factor the number, it contains all the prime factors of whatever number we want to be a multiple of, right? Now the word common means that this particular number is going to be a multiple of this, this, and this. So it's going to have all the prime factors are going to be common. Well, I wouldn't say that way. It's just, it's a they're just trying to tell you it's a multiple of all three of those numbers. That's why they're saying common multiple. And then the last number word here to describe this word is least. So one way of finding a multiple of all those numbers is just multiplying all those numbers together. But the problem with that is normally that's not, sometimes it is the least common multiple, but normally that's not the least common multiple. So it's not the smallest number that satisfies being a multiple of all three. So the prime factorization of 15 is 3 times 5. And the prime factorization of 6 is 2 times 3. So we need to find a number, the least common multiple, that is a multiple of 27. It's a multiple of 15, and it's a multiple of 6. But I told you, if it has to be a multiple of 6, it has to contain all the factors in the prime factorization of 6. So that means in order for this number to be a multiple of 6, it has to contain at least 1, 2, and 1, 3. And so I'm automatically going to put those numbers in the least common multiple, because now, at the very least, it's a multiple of 6. Okay, in fact, multiply that out, it's 6 itself. Okay, now I need to look at 15. In order for this least common multiple to be a multiple of 15, it has to contain all the prime factors of 15. And namely, it has to contain 1, 3, and 1, 5. It already has a 3 down here, so it doesn't need another 3. So we just put the 5 down here. And now we see that it has a 1, 3, and 1, 5. So it does contain all the factors of 15. See, the factors of the 6 can be there, but they can be overlapping with the factors of the 15. That's okay. All right, and then it also has to have all the prime factors of 27. So it has to have 3 3s, and I already have 1 3, so all I have to do is add 2 more 3s. Okay, so we can just kind of double check this, that it has all the factors of 6, it has at least 1 2 and 1 3, it does. It has all the factors of 15, it has at least 1 3 and 1 5, it does. And it has to have all the factors of 27, so it has 3 3s, and it does. And so this is the least common multiple. Notice if I take away any number, you take away this last 3, all of a sudden it doesn't have 3 3s, and it's no longer a multiple of 27. So I can't take away anything. If I take away the number, then it's not going to be one of the multiples here. So this is the least common multiple. And we could just multiply all the numbers back together, and we'll actually get the number that this is. So it would be what, 6 times 5, which would be 30 times 9, 270? 30 times 9. I believe that's 270. If we do it again, we would do it, well, it's 27. Well, no, let's do 2 times 5 is 10, times 3 is 30, times 9. Yeah, 30 times 9. Is 27. All right, so that's our least common multiple. All right, well, let me know if you have any more questions. Bye.